Hi, let's look at this LeetCode question minimum window substring, the 76th one from LeetCode. So the example that is given here is they have given two strings S and T, and we have to find a minimum window substring that will include all the elements from T, which is in this case A, B, C. So the valid windows in this string are A, this one, because this substring has all the elements which is A, B, and C, and D, um, yeah, this one. So there are many substrings which have the elements A, B, C, but we have to find and return the minimum substring that has all the elements. So let's look at the example here. So that's the same example that I'll be taking. Let me write down the string. So this is the S and this is T, right? So if you had checked out my permutation and string question that I have recorded before, you will see that this is a variation of that permutation and string late code question. So in that question, we basically did take two dictionaries and compared those two dictionaries to see whether that the second string exists in the first string. So the idea is a little similar here. So first, we need to take a dictionary here as well to store the all the elements from T. So the dictionary would look like A equal to 1, B equal to 2, and C equal to 1. Sorry, B equal to 1 and C equal to 1. So this dictionary will have the elements related to T1. Sorry, T. So now we have to take another dictionary as we don't essentially take all the elements at once and then put it in D, but we have to just iterate through S. So for example, when you have index, which I'll be taking as right. So when your right is at 0, you traverse, so the element is A, right? So when your element is at A, we basically check if your S of A exists in D1. So if it exists in D1, then we'll add it to D2. Otherwise, we don't add it. So now at index 0, when your right is at 0, your D2 will look like this. And uh, when your right is at 1, you're not adding D to D2 because it doesn't exist in D1. When your right is at D second index, this is O, right? So we will not be adding that to D2 as well. And when your right is at 3, B exists in D1. So we will add it to D2. So when your right is at 4, E doesn't exist in D1, so we're not adding it. So C does exist in D1, so we'll add it to D2. So now when your right is at 5 and your left is at 0, so your D2 will look like this. So this is a valid window now. But I mean, by looking at it, we just know that it is a valid window. But how do we know it through code? We can't definitely do D1 equal to D2 like how we did it in permutation and string question, because it was a fixed window question. So there were and they didn't ask us to return the minimum substring that had all the elements of the second string. So but here they are asking for a minimum window. So even when we have come across a valid window, which is this in this case it is this, right? So it starts from 0 index and ends at 5. So this is a valid window, but we have to shrink the left. I mean, we have to increment the left and shrink the window so that we might come across a smaller window which also has a same number of elements as T. I mean, the same unique elements as T. So The another reason is that if our window would look like this, so even this will be our valid window, but this is a valid window basically. So if we have a window like this, our D2 would look like A equal to 2, O equal to 1, B equal to 2, and C equal to 1. But your D1 is completely different. So your D1 is this one, right? So if you compare D1 and D2 now, you will it will basically not satisfy the condition, and you will end up missing out on windows like this. So we can't do D1 equal to D2 in this case. So let me just clear it. Okay. So as you know, so while you iterate itself, we have to fill in uh, D2, right? So if A is present in D1, so D1 is A equal to 1, B equal to 1, and C equal to 1. So A is in D1, so our A will become, D2 will become this, and we have to also the, check whether um, we have the number of elements. So it's like your D1 has A count as 1, right? So unique elements that are there in D1 is 3. So the length of the D1 will be 3, and whenever we see one element that is in D1, that means we have already found one element. So we will take a variable have for it. So let's take a variable have, and then because we found an element which is in A, we will add um, the have. So have we will initialize of course to 0, and then we'll increment have. So which essentially means that we have encountered one unique element which is in D1. So now the other number so the other unique elements that we have to encounter now is 3 minus 2, 3 minus 1. So because we already have as 1. So let's consider this 3 as so this 3 comes from the length of D1. So you have to compare need. Let's say this is need, and let's say this is have. So your have should be equal to need, and that is when your uh, window becomes valid. So it at this position your window is valid because your have. So at this point, uh, you have at this you have as 1 at this point, and have as 2 at this point, and have as 3 at this point. So now your have is 3 and need is also 3. So because you have and need same, so both, because both of them are equal, your window is valid. And then once you go into the window, of course you have to shrink it and take the element out of D2. So you will take the so leftmost element you will delete, I mean decrement, and if it is equal to 0, then you will delete. But before doing that, you have to make sure if D2 of D2 of the left element which you are dropping is less than um, D1 of S of left. So that is before you delete the D2 of S of left if it is 0. So what this condition will tell you is, it will tell you whether or not you have to decrement have. Because if you're shrink, so, okay, so this is until fifth element, fifth index is a valid window, right? So if you're deleting the leftmost element, which is a, we have to decrement d of a by 1. So when you're decrementing this, and if we do not have any other a in this window, which is starting from 1 and 5. So what will happen is, if you keep your have as 3, your condition again is satisfied. But we don't want have, because we don't want have to be 3, because if your window starts from here until here, there is no a in this window, so your window technically has to be 2. So after you decrement the leftmost element from D2, you have to decrement the have as well. And of course, after you decrement have, you should also delete D of, um, if this one is equal to 0, then you just delete it from D2. Yeah, so in between all of this, you have to also keep a count of um, not a yeah, I mean, you can keep a count, or you can just keep a record of uh, the valid window. For example, if we know that this was a valid window, right? So we can keep a count of this window, which would be the right minus left plus 1 is your window size. So if this is less than your valid window that you have seen until then of course you will um, your new string that you need to return would be equal to s of left to right plus 1. So this will be your new window, especially if it is valid. So yeah, so this you will only, basically you will replace the string always with the valid window, but it has to have the minimum length. Okay, now let's see how the code would look like for this. So of course we'll take a variable left equal to 0, and then we'll take a dictionary for to store elements of t1. So now we'll loop through t1 first, sorry, t. So now your okay, this has to be d1, this has to be d1, this has to be d1. So now your d1 has all the elements and their respective counts of t. Now let's loop through s. So as I said, we have to add s of right to d2 only if it is present in d1. Okay, there is a possibility that it could already exist in d2. So if s of right in d2, then we'll just add it, or we'll do s of right equal to 1. So what this basically does is it'll um, if your s of right is present in D1 and if it is present in D2, then it'll add so D2 of s of right will be incremented by 1, otherwise it'll just be initialized to 1. So now we have to see yeah, so we have to check if D1 of s of right equal to D2 of s of right. So as I said, I told you that we have to take a variable to um, check if the unique characters in T will initialize that with the variable need, and um, the unique characters in the window that we are the current window will represent that with have. So I'll take have as 0, and then so if this condition is satisfied, then we'll increment have, but uh, we have to make sure that s of right in D1 and s of right in D2. So only then we compare, right? Otherwise it'll throw an error. Okay, now we have incremented have, especially if there is that element in. So if D1 of that element and D2 of that element, the count, if both of them are equal, we are incrementing it. And then now um, we'll check the condition have equal to need. If have is equal to need, which means from this example, you can see that at fifth index is when we'll have equal to need. So have will be 3, yeah, have will be 3 and need also will be 3. So, but we have not initialized need. So need equal to, no, after your D1 is when you need to initialize it. Okay. So when your have is equal to need, you have to, that is a valid window, so you have to keep shrinking it. So D2, before shrinking it, uh, we have to delete that element from D2, right? So S of right, sorry, left. You're deleting, you're removing the leftmost element. So D2 of S2 of left minus equal to 1. But we have to also make sure if S of left in D2, because we know D2 will only have the elements that are in D1. So if you're trying to access the if you're trying to access the if you're trying to remove the element which is not in D, then it'll throw an error. So if S of left is in D2, so then you'll decrement it by 1. And if no, if SD of S of left equal to 0 after you decrement it, then we'll just delete D of S of left. But before that, we also need to make sure we decrement have. Uh, yeah, to decrement have, we have to make sure that the element that we are removing, which is the leftmost element, has lesser number in than no, the count of S of left in D2 should be less than the count of s of left in d1. So d2 of s of left is less than d1 of s of left, then you decrement you have. And then after you decrement you have is when you will check for this. Otherwise, if you can't access that element if you're directly deleting it. So after this, so we need to also keep a count of the length of the valid window, right? So I'll just take a mm, okay, let's take a length variable here, and it will be 0. No, we'll take a, because we need a minimum one, I'll be taking a infinite length variable, and then now I'll update the length to, yeah, minimum of length and right minus left plus 1. So your length of course will be updated to this only when the window is valid, because only when have is equal to need, then your length will be updated, and it will keep the while loop keeps repeating itself until the window is valid. Now we have the length, but we need the string to return. So let me initialize the string as well to, no, I don't know. Do I do this? Okay, let me just try. S of left to right plus 1 is your string, and I'll update the length to length of string. I think this should work. Let me print the string. Valid syntax. D2 is not defined. Okay. D is not defined. Where did I mention D? Okay, so okay, it's D2, not D. Cannot access variable string. Yes, we have to initialize it, I believe. Hmm. Okay, so we haven't initialized our left. Sorry, we have not incremented our left, I think. What did we do wrong? This, okay. This has to be inside this. So if s of left is in D2, that is when we'll decrement it. Decrement the s of left from D2, and then after you decrement s of left from D2, that's when you will check uh, if D2 of s of left is like okay, and then I think this should work. Yeah, we're now printing. So you can see that we are returning B, A, and C. We are returning A, which is what is expected, and we are printing yesterday out nothing. So expected is this. Okay, I think string is also, we've initialized it to empty string. So yes, because we initialized it to an empty string, that's what we're returning. And then now let's submit. Oh, there is some later. Let me see. Okay, so I understood what went wrong here. So we are updating the length whenever we see a valid window, but we should only update it when the current valid window has a lesser length than the previous valid window. So I'll check if right minus left plus 1 is less than length, then I'll update length to right minus left plus 1, and then I'll update the string. Yes. Okay. So this is a tricky question, tricky sliding window question. So this is a, when you look at it, it'll look very simple, like how we solved the permutation and string question, but it is a little tricky. So we just have to remember that whenever we find a valid window, we have to stop there and then decrement left and then remove the leftmost element from the dictionary and then compare the uh, so yeah, we have to have and need two variables to make sure that we have all the elements from T in the valid window. So that is how we solve this LeetCode hard question, the 76th one.